So jumping right into the next section on determinants and Kramer's rule. Determinants and Kramer's rule. Determinants are pretty easy to calculate once you get to see what they are. It almost looks like an absolute value bar with some numbers in it. Okay, so it's kind of like a matrix. But it's got these things that look like absolute value bars, and these are the bars that mean to tell you that we're going to calculate what's called a determinant. So I do need you to write that down. No sheet for that. And the way that you're going to calculate the determinant, there will be numbers in these spots. Okay, it's pretty simple process, but the way you'll calculate a determinant is you're going to multiply A times D and then subtract B times C. It kind of almost makes like a swoopy round thing like this. So you're going to be taking AD minus BC, and that's going to give us a number called the determinant. Oh, okay, sure. Band-Aid method. I don't know. Like maybe a butterfly Band-Aid? Like that. I don't know. So AD minus BC. And when we learn about Kramer's rule, it's another way of solving for X and Y and Z. The thing that I like about it is that people can do it pretty easily without a calculator, but the thing that I don't like about it is that it's just a little strange, and it's not really very clear as far as why it works, but just know that it works. And I usually don't like things that are just like do that just because it works, but we're going to take a look, and that's just where we would have to be on this one. So I want to calculate the determinant for this. 2, -8, 3, 1. I'm going to actually write that in on one of these. 2, -8, 3, 1. 2, -8, 3, and 1. And I want to find this determinant. So in order to do this, I need to multiply down around this way. So I need to take 2 times 1 minus -8 times 3. So pretty nice process. We end up with 2 plus 24. And good job, you had said 26 a minute ago, because really that's all there is to it. Choom, choom, like that. So determinants, we like determinants. We just need to know what they are, because there's no way you can look at that and guess to do that unless somebody's taught you that this is what we're doing when we're finding the determinant. So the determinant's just a single number. Just 26 in this case. So we like that. Or at least I like that. It's pretty simple. Now, determinants when you get more than a 2 by 2 are not quite so simple. Okay? Determinants when you get to a 3 by 3, there's a couple of different ways of calculating them. We're just going to look at one of them, and it's called finding the determinant by minors. And when I say by minors, when I say by minors, it means that you're really going to be calculating you're going to be calculating 3 2 by 2 matrices with their determinants to go with these. And so it's, once again, the calculation process is pretty easy, but it's a matter of you can get bogged down in the fact that because it's 3 by 3, there's several things to do about it. So let me just bring this up here, and I'm going to just take it just a little bit at a time. Okay. So breaking it down by minors, if I want to find the determinant of this one becomes a scalar, and it's multiplied by this determinant down here in the lower right corner. So this is our first part. And so you have this A1 times B2, C2, B3, C3. So you're taking this here times this little box of numbers right down here. Then, after you take this number here times this little box of numbers right here, the determinant of them, we subtract the middle one times the little determinant of numbers formed by these two numbers and these two right there. So it's kind of like by the tops and the bottoms. So it's this one times this little group for determinant, then the second one times these two for determinant, and then the third one times the other two. So you're always going out of your row into the other two rows to get those numbers. So there's a minus for this, and there's a plus for this, and then the individual numbers that go into them. So a whole different process for finding a determinant by what we call minors. So everybody's got to have this formula down before we can do anything else. And then we're going to go through actually solving one. So you go ahead and write that down. Now I'm going to bring this to where it's going to allow me to write it, to write on it. We're going to take a look at this. I'm going to try to stay with the colors so that we can do this. All right, so we're going to work very carefully. The biggest danger in these is getting lost in the numbers and not being very, very careful. So what I want you to do is I want you to follow this pattern. We're going to go with A1. What number's in the A1 spot? 1. Well, the numbers here are in those spots, so they're not going to be like labeled like this, but we have numbers in the 3 by 3 matrix. This is just the process for finding the determinant of a 3 by 3 matrix. So you have to have numbers in there, yeah, for what we're doing with it. So then what numbers go here? What number goes here? -2, and then next to it would be -3, then under would be 1 and 2. All right, so we have that piece. Then we need to subtract, and then what number? -1 times what goes up top? Which one? 3? A2 is -1. It'll be a plus when we're done. Yeah, I'm just putting in numbers now. So the top will be 3, -2 from here, and then 1 and 2 from the bottom. And then we do a plus. And we need to take a look at what we're adding. So we're adding the 1 times the determinant of 3, -2, -2, -3. All right, now we can go through and we can begin to actually simplify this. So here you're taking 1 times, we need to swoop down and around like this. So -2 times 2, -4, minus negative 3, which is 4 plus 3. All right. Then the next one, minus negative 1, is plus 1 times 6 minus negative 2, which is 6 plus 2, but just for the sake of people seeing it. And then plus 1 times negative 9 minus 4. And then we can simplify each one of those things. So negative 4 minus negative 3 is negative 1. One times, and we've got a lot of ones here. 6 minus negative 2 is 8. Minus 13. And then, so our final answer is 7 minus 13, which is negative 6. Our determinant of this array of numbers is negative 6. And yes, question. How did you do it? Did you still get a negative 6?
Well, I erased it because I was like, she's probably doing different. But I was doing the A, D, B, C for all of them, and then adding them together. But I did get the E.
Wait, you did? Did you get negative 6 for your final answer? Because yeah, because I'm not sure what you're saying that you were doing. Okay, Samir? Because you do this minus whatever's here. And since here it's negative 2 times negative 2, that gives you positive 2. So that's where that comes from. And let's just double check and make sure that, yep, negative 6. So the one that I did more slowly here, but we had the opportunity to do that. That'll be a great place for us to end for the day. So we've got a good start on that for the determinants, and then we'll talk about Kramer's rule on